Yeah, and here we consider question 8 of paper 1, pure mathematics 1. The code is 9709/12, which was taken October, November 2023. And question 8 reads, oh, sorry, it's far. Okay, there it is. The functions f and g are defined by f of x is equal to x plus a squared minus a, for x is less than or equal to minus a. And the function g of x is equal to 2x minus 1 for x found in real numbers, where a is a positive constant. Find an expression for the inverse of f of x. Then b, state the domain of the function of inverse of f. Roman 2, state the range of the function inverse of f. So here state the domain, here state the range. But C, given that a is equal to 7/2, solve the equation g of f of x is equal to 0. And yeah, that's it. So let's see what our solution should look like in that case. So the question, we are given that there are two functions. We have function f of x. Function f of x is given by x plus a squared minus a, and the range is that x is equal to or x is less than negative infinity. And the other function we have is g of x. G of x is given by 2x minus 1 for x contained in the set of real numbers. So what then we have now, where a is a positive constant. This is a positive constant, and that positive constant, yeah, where a is a positive constant. Okay, right. Find an expression for f inverse of x. That is 3 marks. An expression for f inverse of x. 1. So if f of x is given as x plus a squared minus a, that is f of x. Then for us to get f inverse of x, we'll have to say that, we'll just say without implying, that y is equal to x plus a squared minus a. So I want to make x the subject. If I do, this will then now imply that x plus a squared is equal to y plus a. 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 And that means that x plus a is equal to plus or minus root of y plus a. And so x will be minus a plus or minus root of y plus a. Now that is x. So x is supposed to be minus a plus or minus root of y plus a. Now, since x is less than minus a, x is less than, actually it's equal to or less than minus a, we take the negative value so that we maintain this restriction. we take the negative square root. We take the negative square root here to maintain the restriction. So it means that x will be, that should imply that x will then be minus a plus or minus, not plus or minus, now strictly minus. Now it is strictly minus x plus a plus x minus a root, that is x. And therefore, no, this is y, this is y, this is y, this is y plus a. And so, f inverse of x will be minus a minus x plus a root as such. That is the inverse of f of x. That is the inverse of f of x. It is minus a minus x plus a root. Part B1. State the domain of the function this. So state the domain of the function f inverse. That's 1 mark. So here we see that this is the function. Actually, this is the inverse of this. This is the inverse of this. And this is the inverse of that. So what we would say, the domain of f inverse is the range of f of x. So the domain here becomes the range here. The domain here becomes the range. So since f of x is defined as such, that is x plus a squared minus a, and x is less than a, the minimum value of f of x occurs when? Where does the minimum value of x occur? It occurs where x is equal to minus a. So let's see. Let's bring it here. So if I have f of x is equal to x plus a squared minus a. So the minimum value that f of x can ever get to is minus a, in which case the whole of this is 0. And the whole of this can only be 0 if x itself is minus a, so that minus a plus a is 0. So for x equal to minus a, f of x is equal to minus a. That's what we have. When x is equal to minus a, f of x equal to minus a, and that's the minimum value that it can take. So we say, so for x less than minus a, f of x increases. Now what happens to f of x? If we get values which are less than minus a, and values which are less than minus a have to be found towards the other end, so that if we add a, b, c, d, so a will be bigger, b smaller, it gets smaller as we go towards the negative end. So it means that for x values which are on the negative end, this, we want to see what happens to, because that's the restriction, x is less than or minus this. So we want to see, we have seen a situation where x is strictly equal to minus a here, and we see that the function therefore becomes minus a. But now, what if it is less? And when it's less, that is still consistent with that. So when it's less, now let me take, in that case, if it is less, then what will be happening is that, suppose we said that, now by drawing, what will happen is that the function will be increasing. The function will be increasing because where it is strictly equal to minus a, this will be 0. When it moves a unit difference, the square will be some value. And so it will be increasing. So f of x will be increasing. And so what we say, f of x increases. So the range of f of x, now it will increase up to what point? X can take any value because it has a freedom to take any value. A value up to a point where it's not bounded because it's a variable and there is no limit as to the value it can take. All we know is that it can take values which are less than minus a. So if we said a is minus 1, then x will definitely assume values from -2, -3, -4 up to. Yes. So in that particular case, the range, in that particular case, as that happens, this f of x becomes bigger. It's getting bigger. Yeah, the result of all this is getting bigger. So what we are going to have is that, so f of x increases. So the range of f of x, the range of f of x, the range of f of x, so the range of f of x, the range of f of x will be minus a and infinity. No, this infinity is unbounded because we don't know. So we give it that. But this we know because it is strictly equal to this. And that happens when we have this to be 0, we see that that's what we have and it's the lower boundary. That is it. So this becomes the domain. This becomes the range of f of x, the range of this. This is the range. This is the range of this. But what we are saying is that the domain of f of x, the range of f of x, the range of f of x is the domain of the inverse. So it means that the domain, so this will be of f of x, but again, it is still the same for f inverse of x. Yes, still the same as such. Roman 2. State the range of the function. So we had stated the domain of the function, Roman 1. Now state the range of the function f inverse. State the range of the function f inverse. Now, so this we have stated, this was the range, and this the domain. We are now asked to state the range of the function f inverse. Yeah, this is just the domain. So we need to state the range. So we say the range of f inverse is the domain of f of x. The range of f inverse, the range of f inverse of x is the domain of f of x. Is the domain of f of x, which is x is less than minus a. X is less than, so let's see this. So let's see the domain here. The domain. Let's define the domain. So it means that x being less than or equal to minus a. If we took a to be 1 as the constant, so it means that x can take values -2, -3, -4, -5, -6, throughout up to minus infinity, up to minus infinity. So it then means that that is where the function is going to start. It starts because the function, it moves from the minus going that way. So it means that the domain will actually begin from minus of infinity, in which case We give it this because we don't know, it's not bounded. But then it comes up to the point where it meets our constant A. And that's our curve. So that's our curve. That's how this particular function is supposed to move. Our curve will be defined where this particular end on the negative end, the x values is not bounded, so it can move. But when we are approaching A, as we go this negative A, as we go this way, as we approach 0, then we meet a constant. We meet a constant beyond which we cannot go because we have x less than or uh, x equal to or less than minus A. So what we say thus, we say that thus the range of the f inverse of x is this, because it's that this is the domain of this. Yes. So we say thus the range of f inverse of x is minus infinity to minus A, since the range of f inverse of x is the domain of f of x. Okay, part C. Part C. Given that A, this part C, given that A is 7 over 2, solve the equation G f of x is equal to 0. So, first of all, what we need to do is find, so we are told given that, that is that. So what we need to do first is to, because we are told that this composite function is equal to 0. But then, first, what is g f of x? G f of x is given by the expression. So first, we need to get g f of x, then equate g f of x to 0. Yes, but x is given by this, and f of x is given by this, and g of x is given by this. So if I want g f of x, then I'll simply be saying this is 2 into f of x minus 1. Minus 1. So where there is x, I put this. And that just meant that I have 2 into x plus a squared minus a minus 1 like that. Minus 1 as such. So I can open the bracket, I can open up the bracket, but first let me see what I have here. X plus a, this is x squared plus 2ax plus a squared. So I'm going to have here 2 into x squared plus 2ax plus a squared minus a minus 1 minus a minus 1, like that. That's what I'm going to have, minus 1. So opening up the brackets here gives me 2x squared plus 4ax plus 2a squared minus 2a minus 1 is equal to 0, because we are told this is equal to 0. So I equate it to 0 because now I want to solve. So now I can now, let me see, but We are given the value of A to be this. We are given the value of A to be that. So we can substitute the value of A and see what we end up with. So in that case, I'll be having 2x squared plus 4 times 7 over 2. 4 times 7 over 2, that is 7 over 2 times 4. That's 14. So I have 14x. So it's plus 14x. It's plus 14x. Plus A squared will be 49 over 4. So times 2. 49 over 4 times 2. So 49 times 2, that's 8. 98, yeah. So I'll be having plus 98 over 4. 98 over 4 minus 14 over 2. No, minus 14 over 2. Minus 14 over 2. Minus 14 over 2. And then minus 1 is equal to 0. So what is all this? Let's see what all this gives us. What that gives us. So I have 98 over 4 minus 14 over 2 minus 1. So I'll be having 4 is 98 minus 28 is 4. So that gives me, that's already 70. 70 minus 4. 98 minus 28, that's 70. 70 minus 4, that is 66. So we get 66 over 4. We get 66 over 4 in that case. And you see, so we have 2x squared plus 14x plus 66 over 4 is equal to 0. I want to multiply every term by 4. So if I do that, then I'll be having 8x squared plus 56x plus 66 is equal to 0. Plus 66 is equal to 0. So is there a number that can go in all of those? 2 can do. So if 2 does, I'll be having 4x squared plus 28x plus 33 is equal to 0. So that's the farthest I can go. Now I need to solve for x. Solving for x. Solving for x. Solving for x, I want to apply straight away the quadratic formula since those values are because having to get those values because I'll be having a product of 33 times 4. Let me see, 33 times 4, that's 12. That's 132. So you want two values which will give you a sum of 28 and a product of 132. $66. So we have 6, 12 and 11. No, 12 and 11 cannot be. So let's straight away get to the quadratic formula. So the quadratic formula will have it that x is given by minus b plus or minus b squared minus 4ac root all over 2a. And our a in this case is 4, b is 28, and c is 33. C is 33. Let's see what we get. So x will then be minus b, which is minus 28, plus or minus square root of b squared, which is 28 squared, minus 4ac. So 4 times 4 times 4 times 33. Yeah, that root. Everything divided by 8 because it's 2a. Since it is 2a. So first we need to simplify. If we simplify what is inside here, then we'll be good. So let's see. 28 times 28, that's 16, 4, 5, 0, 4, 16, 16 plus 6, 22. 784. 28 squared should be 784. Then minus 16 times 33. 16 times 33, get 840. 8, 2, 528. So 784 minus 528, what do you get? 14 minus 8, that is 6. 7 minus 2, that is 5. And 7 minus 5, that is 2. 256. So we get here x is equal to minus 28 plus or minus root of 256 over 8. Then what is that root of 256? What is it that if we square, we get 256? Let's see 14. 14 will be 196. So 256, root of 256. Okay, let's find it. Let's find and confirm if by taking a positive side, the root you find here, if by adding and dividing by 8, you get the value. If by subtracting what you find here and dividing by 8, those particular values, see to it that the answers that you are getting are, because I don't want to get to my calculator, the answers that you are getting should be at least x is minus 3 over 2 or negative 11 over 2. The x values that you should get. And what we see, just remember, from where I picked the quadratic, where I started doing part 3, I picked the quadratic as it is. But we could as well take the case that f of x, just a short way, is x plus a squared minus a. So by substituting this straight away, a, because a is already given as 7 over 2. So we could say straight away that f of x is equal to x plus 7 over 2 squared minus 7 over 2. So you shall have substituted already. So by doing that, that will make it a little quicker. So you need to find the value of f of x, given that we had g f of x to be, we had g, just a minute so that I don't lose it. Given that a is that, solve the equation g f of x is equal to 0. Now g f of x is equal to 0, meaning that this, you first find this when it's equal to 0. think I've messed it up. Let me just stop and start again.